Hey everyone, welcome back. In this video we're going to continue talking about lines and linear functions, because that's the unit that we're working on, and we're going to be specifically working on a problem that's very similar to the one that we were doing yesterday, well, in the last video. So the last video we had an equation like this. We had y equals 2x minus 2. I believe is the equation that we had. So we had a slope that we had to worry about. We had a y-intercept that we had to worry about. So if I was writing this without the numbers, we had a line where we had to worry about all of these components. We had the m that we had to worry about. We had our slope, and we had our y-intercept that we had to worry about. So what we're going to do today, just so I can really highlight what the different components of the equation do, is we're going to graph a function that's very similar to this one up here. Then we're going to graph the exact same thing, but we're going to get rid of the intercept, so it's just going to be some number times x, and we'll keep that number the same. So if this one, so like if we were doing this same one as the last video, I'd keep the 2 the same. I'm just going to ditch the minus 2, and then we'll graph the same equation again, but I'll get rid of the slope. We'll make the slope equal to 1. And so that way you'll be able to see what happens when you change the slope, what happens when you change the intercept, and we're going to graph them all on the same plot so that you can tell the difference. Once again, I've got blue and red markers out that will hopefully come in handy, but if not, I'll end up just writing the equation for each line beside the line that I've drawn. So what we're doing today is we're basically examining the equation of a line, so we'll write that down as a title. We've got examining the equation of a line. All right, great. So this is what we're going to be doing today. We're going to draw out a plot very similar to the one that we finished with in the last video, so where we have the x-axis kind of running through the middle. So we're going to set up our plot that exact same way. And what I'm thinking is we'll plot the first line, sort of the most complicated one with the slope and the intercept, with the table, so with our trusty old XY table of values over here. So we've got x over here, we've got y over there, and we'll end up picking some numbers once I write down the equation. But then what we'll do after that, when we're graphing the two sort of simpler versions, I'll show you how to do that. For both cases, I'll show you how to do that without the table. We'll use the shortcut for those just so you can sort of see it in action. I don't think we'll need to go particularly far down the axes here, so 6 in that direction seems fine. 1, 2, 3, 4, 5, 6. And then over here we got 1, 2, 3, 4, 5, 6, 7. All right, that should do it. We probably won't need all of that space, but hopefully this will be enough to give you guys a rough idea of what all of the different components of the equation do. I say all like there's a whole bunch of them. There are only 2, so I should be saying what both components of the equation do. It's really not as complicated as some of the other stuff that we could have been doing right now. So last time what we did was y equals 2x minus 2. We're going to change it ever so slightly because I don't want to make it more complicated. I just want to highlight some points in this one. We're just going to make it y equals 2x minus 3. And so we'll start off by constructing the table. I'm going to redraw this table, actually. I need some more space for that. So we'll start off by plotting this exact function using the table, and then we'll use the shortcut for the other two. So this video might not end up being 40 minutes long like the last couple have been. But I think you guys wouldn't mind getting a little bit of a break if this one comes out to be a little bit shorter than that. So, yeah, so we got 3 lines we're going to graph today, and the first one is going to be this one right here. So we got y equals 2x minus 3. All right, let's choose some x values. Since we're not using any negative x values, oh, he didn't I hope you guys didn't forget that to label the axes, but make sure you have them labeled. So we don't have any negative x values going this way. So we'll start with an x value of 0, an x value of 1, an x value of 2, and an x value of 3. We'll keep it simple for this one so that we can plot our function here. Now let me see, just in case it ends up being somewhat helpful, if I can put some dotted lines to help with the graphing, just because yes, we're going to have a lot of stuff on this plot, but I think it'll be helpful to have something like this as well, just so that we can really see where all of the different points are actually landing. Because once you have a whole bunch of stuff, it can be really easy to sort of lose sight of where all of the lines are. So I know those aren't perfectly straight. I'll see if I can straighten those out a little bit. That's probably too much in the other direction, isn't it? Actually, no, that's okay. It's this one that's a bit of a problem now. And it's a little bit out of line with the 4. Okay, whatever. I'll fix this. But anyway, yeah. Hopefully this doesn't clutter up the graph too much. But I think it'll be really helpful to have these grid lines at least on the whiteboard. You guys don't have to have these on your paper. And I know graph paper is kind of hard to come by there, so don't necessarily don't be pulling your hair out trying to get graph paper, because it's not really going to be the most important thing. In the next unit, we will be doing more graphing stuff as well, but again, I'm going to keep it to some reasonably simple cases so that we don't have to worry too much about it. These lines are not perfectly straight, but hopefully they'll serve as a little bit of a guideline so that you can see what's going on. Now, if you guys haven't already taken it upon yourselves to start this, you could try to find the first couple of y values for the table while I'm finishing this thing over here. And you know what? I think that'll do. We don't need the -6 one down at the bottom there. So we've got our plot that looks something like this. Hopefully your lines are a little bit straighter than mine. Yeah, so let's try and calculate some y values. So we've got just about enough space. We'll try and fill out little equations to calculate all 4 of the y values that we need. So the first one, we put in x equals 0, and that's going to give us, let's see if I can bring this a little bit closer just while we're working on the stuff with small writing. So that's going to tell us when x is equal to 0, y is going to be equal to 2 times 0 minus 3. Right, so we've subbed in this 0 in place of the x in the equation, and so that's given us 2 times 0 minus 3. So 2 times 0 is 0, minus 3, so we get an answer of -3. So that -3 we can plop down right here beside x equal to 0. Next one is x equals 1. So that's going to give us y is equal to 2 times 1 minus 3. 2 times 1 is 2. 2 minus 3 is -1, so that goes there. And we can put that -1 down there. Next up is x equals 2. And you don't have to write out the calculation every time, but it does help, especially on like a test or something, for whoever's marking it. If you're not writing any of your steps and you happen to do something wrong, it's really hard to give you sort of part marks for the question. But if you write out what you're doing here, and then somewhere instead of doing 2 times 1 minus 3, you did 2 times 3 minus 1 or something, you messed up the calculation somewhere, at least we can see, that you sort of had the right idea, especially if the rest of them are right, you can see that you sort of had the right idea and give you some of the marks for it, right? Also, if you're looking at your test and there's a question there that says, find the y-intercept of this line, and it's out of 3 marks or something, 3 marks or 4 marks or 5 marks, chances are we're not looking for you to just write down, the number 4, And that's it, without showing any reasoning behind how you got that answer. Now, if you're taking a guess, take a guess. But if you know how to do it, try and show as many steps as you can. So that's why I'm trying to write out all of these things on the board so that you can see the logic and the reasoning behind all of these things, and hopefully to get you in the habit of also doing the same thing when you're doing your assignments and your tests. All right, so this next one, I lost where I was going with the actual math. So we got x equals 2, so that tells us y is going to be equal to 2 times 2 minus 3. 2 times 2 is equal to 4. 4 minus 3 is 1. So that gives us our next point here. Now, from our table, you can see we've got a bit of a pattern going on down here. We've got -3, -1, and 1. So it's always increasing by 2. Right? We've increased by 2 there. We've increased by 2 here. And on the x side, we're increasing by 1 every time. So as long as we're increasing by 1 on the x side, we can have a pretty safe guess that we're going to be increasing by 2 on the y side. And so we could just put in a guess that this one should be 3. But let's calculate it just to be sure. I'm going to move the x and the y down just a smidge so I've got some space. So for x equals 3, that's going to give us y is equal to 2 times 3 minus 3. 2 times 3 is equal to 6. 6 minus 3 is equal to 3. So we were right to follow the pattern, and we can put a 3 right down there. Great, now we've got 4 points that we can work with, and so let's go ahead and plot them. So the very first one is has an x value of 0, so that means we don't have to move left or right from our origin point here, but we do have to move 3 units in the y direction, and because we've got a negative sign here, we have to move down 3 units instead of up 3 units. So from the origin, we go down 1, 2, 3, and we put our dot right there at 0, -3. Alright, so that's our y-intercept, in case you hadn't noticed that yet from our equation. This bit right here is the y-intercept, right, this -3 on the end. So that tells us where along the y-axis we can expect to find a point, and it's at -3. Not a coincidence. Alright, when x is equal to 1, y is equal to -1, so that means we have to go 1 over in the x direction. That's not really a centered thing, but you know, we'll make do. So we go 1 over in the x direction, and then we have to go down 1 unit in the y direction, and we're going down again because we've got a negative sign over here for y, so we have to go down 1. So that's our second point. X is equal to 1, so we moved over 1, and y is equal to -1, so we moved down. Next one, x is equal to 2, so we go 2 units over from our origin, and we go up 1 unit because we've got a +1 in the y column. So we've got 2 units in x, and then 1 in y, but this time we're going up because it's a positive y value, so we put our dot right there. Alright, we got one more to do. So when x is equal to 3, y is also equal to 3. So we move over 3 units in the x direction, which is the horizontal one, and then we move 3 units in the vertical direction, and we end up with a point somewhere around there. Now that's plenty of points, so we can connect the dots, try and keep it straight. If you have a ruler, use a ruler. If you don't have a ruler, or if you for some reason happen to also be doing this on a whiteboard, then you're kind of out of luck. That's a little bit, is that reasonably straight? I think that's reasonably straight. Cool. Obviously the line's going to be a little bit wonky. The next point should be somewhere up about, let's see, 4 and 5. The next point should be somewhere around there. So yeah, my line's a little bit crooked, but I think you have a rough idea of what's going on. It's just hard to do this without a ruler up against the whiteboard. Something like that. Yes, the next point would be 4, 5. So our next point, this one we didn't calculate from the table, but that's where the next point would be. And so we end up with a line that looks something like this. We can extend that a little bit in both directions. And there's our line for y equals 2x minus 3. Okay, brilliant. I'm going to put that equation right over here. Y equals 2x minus 3, just so we don't forget about it. And I'm going to have to erase some stuff. I'm going to erase this stuff in here. I'll get rid of that box. And I'm actually going to get rid of the table because we're going to be using the shortcut for the next two. And so what I'm going to do, just to show you the shortcut in action, is we'll do the other two equations that we're going to do using the shortcut, but then we'll also revisit this line with the shortcut just to see if it makes sense. So actually, let's go over this line first with the shortcut because it's the only line that we have to worry about, and I don't want to confuse you more with this later. So from this equation, what we've got is we've found our slope is equal to 2, because we know from our equation of a line, y equals mx plus b, we know that m is the slope. So the thing that x is being multiplied by is the slope. So in this case, that's a 2, and then our y-intercept is the thing that's added or subtracted at the end. So since we've got a negative sign, we have to keep that negative sign with our y-intercept, and our answer for the y-intercept is -3. So what this tells us is we know our slope is 2, our y-intercept is 3. So the thing with the y-intercept, that tells us where on the y-axis we should be putting a point. So we've got our y-intercept of -3, which means we should be putting a point at -3 on the y-axis. So that would be this first point right here. That's where we got our y-intercept from. Now, for the slope, so the way we would plot the rest of the points, the way we just did it with the table of values, we always recenter at the origin and then we go 1 unit over, 1 unit down, or 2 units over and 1 unit up, right? We always go back to the origin and then we move. We go back to the origin and then we move. We go back to the origin, we move. Every time we reset at the origin and count from there. If we're using the shortcut, you count from the last point you drew to the next point that you draw, to the next point, to the next point, to the next point. And if the line never passes through the origin, you never have to look at the origin. Oops, I just lost my marker. So looking at the graph that we already have, if we start at this point here, our slope of 2 is telling us, just let's remind ourselves from last video, we had that slope is equal to rise over run, right? But we also know that we have a value for the slope, which is equal to 2, but we wanted to write it as a fraction. So instead of writing it as 2, we'll write it as 2 over 1, which is the same thing, right? And so what that ends up telling us is that the rise is equal to 2, and the run is equal to 1. And what that means is that the rise being equal to 2 means that when you go from the last point that you drew to the next point, you have to go up 2 units. That's what the rise of 2 means. If it was 3 over 1, then we would be moving up 3 units. If it was 10 over 1, we'd be moving up 10 units. So that numerator tells you how many units you have to move up, and then the run tells you how many units you have to move over to the right. So if you had a rise over run of like 3 over 2, if you had a rise over run of 3 over 2, something like that, then you have to, once you've drawn your point, you would go up 3 units and over to the right 2 units, and then you would put your point there. So it doesn't always have to be a whole number. You don't have to get a denominator of 1. Just try and get it into a fractional form, even if it is a whole number, just so that you can clearly see that you have to go up this many units and over that many units. So if we start from our -3 point right here, then we go up 2 units, so that'll take us from -3 up here to -1. But we're still on the y-axis. We still have an x value of 0, right? Because we haven't moved left or right yet. So now we move 1 spot over to the right, and that gets us over here. We move 1 spot over because our run is equal to 1. So we get, we moved up 2 spots, and we moved over 1. So that follows this thing here from our slope. We go up 2 over 1. So we go up 2 over 1. And then from here, we repeat that process. We go up 2 over 1. Up 2 over 1. Up 2 over 1. So it's the same pattern every time. You just repeat that process. As soon as you put down that first point, that y-intercept, everything else is just repeating the exact same process until you have enough dots that you can sort of tell where your line is. Maybe I shouldn't have erased that. Whatever, that's okay. So that's how you could plot this exact same line using the shortcut. Now we're going to plot the other two lines using the shortcut. So let's do that. So the first line that we did was y equals 2x minus 3. The second line that we'll do is y equals 2x. Okay? Now for y equals 2x, let me erase the black circle around the 2. We'll do this one in red, and we'll plot it in red as well. In red? Yeah, sure, let's do it in red. Why not? So we got black there, we got red here. Brilliant. Okay. So, yeah, alright, so we got y equals 2x. So first thing we need to do is we need to identify what the slope is and what the intercept is so that we can use the shortcut. So the slope, if you remember, is the thing that you're multiplying x by. So in this case, the slope is going to be 2. Just like we had in equation 1. I told you we're not going to change up that slope. So the slope is still 2. But now the y-intercept, we don't have anything that's added or subtracted to that 2x, right? There's nothing else being added on or subtracted from this over here. So technically that's the same thing as having a plus 0, right? If I take 2x and I add 0 to it, I still have 2x, right? I haven't changed anything by writing plus 0. And so that way might be a little bit easier for you to see that our y-intercept is 0. So now once we've found that our y-intercept is 0, that means we can plot our point at 0 on the y-axis. So we look at the y-axis, we find 0, we plot a point right there. I should be plotting that in red. So we plot our point there for the y-intercept being at the origin. Now from here, we know our slope is 2, right? So if we have a slope of 2, that means that, well, we know slope is equal to rise over run, which is equal to, in this case, 2 over 1. We've just rewritten that whole number as a fraction. So this tells us that our rise is 2, so we have to go up 2 squares, and our run is 1. So every time we go up 2 units, I say 2 squares, but here I don't mean 2 squares, I mean 2 units, because each square is not 1 by 1. If you're doing this on grid paper, then hopefully you've lined up each square to be one number. Like I should have put more grid lines in the middle of each of these if I wanted to say the squares thing, but we're moving up 2 spots on the axis for our rise of 2, so we move up to here, and then we'll move over 1 unit to the right. So if we plot that, it's going to look something like this. So we go up 2 over 1, and we get a dot right there. And then from this point, we can repeat that process. So from here, we go up 2 over 1, and we end up with a dot right there. And if we do it one more time, we go up 2 over 1, we'll end up with a dot somewhere about there. All right. And once you've got a few of those dots, hopefully I didn't go too quickly, basically all we've done is we've gone up, up, over, up, up, over, up, up, over. That's all we've done. We've gone up 2 units and over 1 unit. Maybe I should have drawn these over here. Up, up, over, up, over. So we've gone up 2 units and over 1 unit every single time, and that's how we've gotten from one point to the next. Once we've got all those points in place, we can play connect the dots, and we get something that looks like this. And there you have it. There's your same line as the first one, but without a y-intercept, right? We've got this plus 0 instead of having minus 3. So when you change the y-intercept, you can see that that whole black line has basically just shifted its way up on the page. If I had drawn this a little bit better, like if I extended this line a little bit more, then maybe it would look more like the black line has just been shifted up the page. If I draw it something like this, or if I'm trying to line up where the arrows stop, then it looks like the black line has just been moved up the page, or moved up on the whiteboard to its new location, which is where the red one is. So that's what happens when you change the y-intercept. That just moves the whole line up or down. Now we're going to do one more. We're going to graph the same line as the first one that we did, except instead of having a slope of 2, we're going to have a slope of 1. So I'm going to get rid of that red. We're going to do this with blue. So we've got line number 3 is going to be, so instead of doing 2x minus 3, this one is going to be x minus 3. So instead of having a slope of 2, we've got a slope of 1 instead. And if it makes you feel better, you can write that 1 in there for yourself. Because the next thing that we need to do, remember, is we need to identify the slope and the y-intercept. So in this case, the slope is equal to, we've changed it from 2 this time, we've changed the slope to 1. And our y-intercept is back to what we had for the first one. Is going to be this -3 right here is our y-intercept. So we've got our y-intercept is -3. So, that's y, there we go. So we can find our starting point because we know our y-intercept is -3. So we look at the y-axis, we find -3 on the y-axis, that's this point right here that we already had from before, the one point that I'd circled. So I'm going to fill it in with blue, because why not? Probably doesn't look very different to you guys, but as long as you can tell what I'm doing and why I'm doing it, then it's all good. So our next point, we need to use that slope equals rise over run business again. So we've got slope is equal to rise over run. That's not as neat as it could be, but hopefully you are getting the idea. Slope is equal to rise over run, which is equal to, in this case, our slope is 1 instead of 2. And if we want to write that as a fraction, that's going to be 1 over 1. So what that tells us is, from our starting point, if we move up 1 unit and over 1 unit to the right, that should give us our point. So we go, from here we go up and over to the right, just 1 unit in each direction, and we plot a point right there. And then we repeat that process. So we're not using the origin at all this time. We go up 1, and we go over 1, and we plot our point right there. And we can go up 1 and over 1, and plot a point right there. We can keep going. We can go up 1, over 1, plot a point right there. And if I stop putting in those little blue arrows, we plot our next one would be right here, and the one after that would be right here. And that should be it. That should be good enough. So now you can see we've got a whole bunch of blue dots going in that direction, and so we can connect the dots, hopefully reasonably straight. Like that. And then a little bit out in that direction as well, because why not? So, there we go. Those are our 3 lines. If I want to put the equation, we've got y equals x minus 3 over here. The red one was y equals 2x, so I'll write that up right here. Y equals 2x. It's just good practice to label the lines on the graph as well. And so there we have it. Those are our 3 graphs from all that all sort of stemmed from the same equation. So we started with the most complicated one, where we had to worry about the slope and the intercept, and we had to deal with its actual angle changing this way, and it was moving up and down. And so that gave us this black line, which isn't at a nice 45-degree angle and doesn't intersect with the origin. So it was moving all over the place. The second time, we got rid of the change in the intercept, so that made sure that it ran through the origin, but it still had this wonky angle going on. So for the third one, we put the intercept back, but we change the slope back to 1. So we've got that nice 45-degree angle over here with this blue line. So you can see going from the black line to the red line, that's what happens when you change the intercept, and going from the black line to the blue line, that's what happens when you change the slope. And if you sort of combine all of those pieces together, from like you take the intercept of the blue line and the slope of the red line, and you piece them together into this one fancy line, you get the black line in the middle. Now we won't be doing anything like trying to add the two equations together or anything like that. This is just to show you what the different parts of the equation do. So what happens when you change the slope, what happens when you change the intercept, and in the next video or so, we'll start going in reverse. I'll draw the line, and we're going to figure out how to piece together the equation based on the drawing. And so the thing that's actually really useful for that is the shortcut. If you can identify the y-intercept and figure out what the slope is based on where the dots fall, you can build the equation simply by looking at a picture. So we're going to practice that starting next class. So if you're not comfortable with the shortcut, try to get comfortable with it. I'm going to put an assignment out not too long from now, so you'll get an opportunity to practice doing it with the table and doing it with the shortcut. And then we're going to be making use of that shortcut when we're running this process in reverse. So I'll give you that drawing, and we're going to be piecing together this side of the board instead of the other way around. So hopefully all of that made sense. As always, get in touch with me through email or, whatever, some of you on Instagram, something like that. Get in touch with me however you see fit. But if you guys don't have any questions, then I will see you all in the next video. Have a good one.